Question number 16 of our Unit 1 test review. We just came from 15. Let's take a look at 16 now. So now, class, the interesting part is this is not a continuous function or table. This is discrete. So we can actually write that right now. Just a set of points. This is a discrete graph. So because of that, we can't actually do interval notation, because interval notation is saying that it's all the numbers in between the lower boundary and the upper boundary. But we don't include all the numbers or all the x values or y values. We just include the values that you see or the points you see on the graph. So for a domain, we're going to use this thing in math called set notation. So I'm going to use a pointy bracket. And take a look. Domain again is our x values. So we've got an x value at -2, -1. I think these are all together. Yep. 0, 1, 2, 3, and 4. 0, 1, 2, 3, and 4. That means our domain is not an interval. It's just a set of these. What are they? 1, 2, 3, 4, 5, 6, 7 points. Okay, how about range? Now we're looking at all of our possible y values. So now we'll look on the y-axis. Again, we start with the lowest one. So on the y-axis, we have 1, and then 2, and then 5, and then 10. So 1, 2, 5, and 10. Again, you see this. Only these numbers are part of the domain. Only these numbers are x values that describe the points. And only these numbers are the values of y that are on this graph. Again, 1, 2, 5, and 10. Okay, interval increase on this. This would be a little bit tougher to deal with. There really is not an interval that we can write here, because intervals, again, have a lower boundary and an upper boundary, and they include all the numbers in between. So we don't really have an interval of increase or an interval of decrease. How about our maximum or minimum point? Oh, I wanted to actually write this on the previous one. The maximum or minimum point is, well, actually, you know what? I don't need to describe that. Let's take a look at this maximum or minimum point. We have a maximum, well, we don't have a max, well, we do have maximum points. So this is kind of weird as well. How do you actually write this? Like, we know there's a minimum point here, so we could say that the minimum point, technically, the minimum point is at 1, 1. And I guess you could say, I'm kind of unclear about this one, because maybe we wouldn't actually say minimum or maximum if it's not continuous. But let's just go ahead and note these. So I've got a maximum point here at -2, 10. And I also have, let's put a colon here. And I also have a maximum point at, take a look at this one right here, 4, 10. Oops, going off my screen. Sorry about that. 4, 10. Now I would say, class, typically maximum minimum is only actually describing a continuous function, because it's clear on question number 15. You can see the graph only gets to this maximum point. But technically, you could say on this discrete function, this is definitely our lowest value on our y-axis, and this is definitely our highest value on our y-axis. So maximum and minimum, if you think about this, we're looking for the coordinate, like connect this. Maximum or minimum is really looking at the maximum or minimum on the y-axis. So this coordinate is the maximum value on our y-axis. These are also maximum and minimum on our y-axis. X-intercepts, There are no x-intercepts on this graph. Nothing is touching the x-axis. And then we already wrote in the beginning that this was a discrete graph. So there you go on that one. I hope that one was clear. Actually, it's funny. It's a simpler graph, but it actually gets a little more complicated when we start talking about these key points or key descriptions of this particular graph. Well, there is question number 16.